Hi, welcome to week 4 of secondary math methods. And this week we talk about problem solving. You remember when you were a student in class, maybe in middle and high school, and you were given 20 problems to solve overnight, or maybe you started at the end of the class and maybe you finished some in your study hall. Then you came in the next day and the teacher would go over the 20 problems, maybe review a little bit for the next section, then assign 20 more problems, and it would continue on and on and on. Well, you probably liked that type of math. However, it doesn't work for most people. And what we're going to focus on this week is developing problem solvers in your class, not just rote robots who solve problems. And the thing about problem solving is that it's something that should be taught at the kindergarten level. And unfortunately, if you teach at middle high school someday, you're going to be getting students who might have not have had practice in problem solving. So you're going to have to change that. If you want to make your life easier in your classroom in terms of getting your students to really think like mathematicians, then they should be problem solvers. If you want to solve some of your problems, your own problems in classroom management, you make it so that they will be working on these problems and being engaged. So there are a lot of resources here that are available. And the first thing before we get to the textbook is from the National Council of Teachers of Math, and this site will be available on Blackboard. It's just a short, brief summary of why problem solving is important. And it's basically, you'll find that they'll give you all of the reasons here, but it gives the students an opportunity to see math as the science of patterns rather than just a bunch of numbers that they have to answer for the next day's homework or the following week's tests. You have to start training your students to become thinkers in that way, because they will not like math. They will fight it, and that's from experience, if it's all about solving as many of these simple problems in the classroom from the textbook. Textbooks can be valuable, but they can also be deadly, so just be aware of that. Talk to your mentor teacher about that. Hopefully he or she is doing this type of teaching in terms of problem solving. So you have to find good problems to solve, and these are sometimes one or two a day, or you have a problem and they work in groups and so on, rather than in isolation, just like in the real world someday when they'll be working on solving problems. And it's always thinking about the science of patterns. Remember that. So in this short essay here, they talk about what types of problems. A problem has to be important, useful mathematics embedded in it. So that can be a challenge. So that's why if you give just 20 problems, which ones are important and what are you trying to get the students to understand? It requires a higher level of thinking and problem solving. Those first few problems that are in the assignments where it's just sometimes fill in the blank, or a simple problem that doesn't really challenge the students. You have to challenge the students, but you have to challenge them at their own level. You can't kill them, because then that would be just defeating your goals, and it would be defeating the students. But you want to make it challenging, and it has to be higher level thinking. I'm not sure if you've learned about Bloom's taxonomy, where with the different levels of understanding, but if you're just talking about memorization, that's at the lowest level of thinking, of knowledge. And if you want them to get to analyze and evaluate, those are the higher level thinking skills. That's what you want them to become. And it has to be the conceptual development of students, so it contributes to their own thinking. Okay, it can't be just something for your own personal take. They're the ones that are important in this case. It gives you an opportunity for the teacher, for you, to assess how they're learning, and also it's self-assessment for you. And it's like a little checkup. How are you doing as a teacher? Are they getting this stuff? Are they able to solve these problems? Okay, and it should be solved in multiple ways using different solution strategies, which the textbook refers to, and which I have another website that will refer to how to do this. And so it has a possible of more than one solution or different decisions. And that's the important thing, is that we'll get to that in a second here, is that it should involve the students to be making decisions as to, just because you get an answer, what does it mean? And that can be a challenge, because I know that talking or writing about mathematics or metacognitive types of things, that's called thinking about how you thought, or showing it's a little bit more than just showing your work. It's talking about how you solved it and what are the decisions that you make. I also teach stats, and one of the things that my students have to work on is that once they found the answer, is that tell me the story behind it. So you just found the mean or median of a set of data. Well, what does that mean to the entire picture? What would you make as a decision? And that gives the students a lot of personal take on their learning. Try it. Engagement discourse, you can do it by writing, you can do it by just talking about it. It really helps. And the problem connects to other important mathematical ideas, and it shows it promotes the skillful use of mathematics and an opportunity to practice important skills. So those are the things, and they also have some examples here. And so you have to think about this as well. Now in the textbook, I've read about, let's see what page this is, 160. I skipped all the way to page 160. It's some problem-solving strategies. You can go online and type in problem-solving strategies. You'll get videos. You'll get anything that you want to give you an idea. So think about it, working backwards. Now, one of the things I did was I gave the student the answer sometimes. You do that, and you have the answer. Okay, how do you get to that answer back to the problem? And it sometimes helps. So sometimes that would be, I don't hide the answers from the students. That's like saying, this is your goal, you got to get there. Now learn how to get there. And you'll be surprised at how much it helps the students. So the answer doesn't have to be a big mystery and a right or wrong, but give them the answer, have them work backwards. So that's one of the ways you can do that as well. And so they have a lot of different types of ways, and the way I just mentioned is not the only one. Finding a pattern. Okay, that's very important. So you can look at this. I don't have to read every single one, but it begins around page 160, and you can use them in your own class. Then there's this other site here. It's classroom cognitive and metacognitive. There's that term metacognitive, which means you are thinking about thinking. How did you get this? In other words, it's a reflection piece, which is very important in all of education, in all of the subjects, but we don't use it enough in mathematics. Usually we just get the answer, boom, we go on. But think about it and see how much time this takes. So that's going to be why you can't give 20 problems from the book, but you give just a few for them to really delve into the problem. They have to be interesting problems. It can't be just a simple fill in the formula type thing, like just factoring an equation. So you have to give them something that maybe they develop the equation and then factor it and show what the answer will mean. That's a little bit more of a deeper understanding of the mathematical process than we sometimes ask from our students. So in this particular our document is it's more of a simple one. You can use this in lieu of the textbook. I wouldn't mind that at all. But you can see that there are different types of models, and understanding the problem is the first step, devising a plan to understand the problem, implementing a solution plan, reflecting on the problem, and that's the metacognitive part. So, and Polya is one of the premier writers. In fact, the author of your textbook also mentions him as well in his book in terms of how to solve it, and he's sort of developed these ways of thinking about problem solving. So it's based on his philosophy. There are different rubrics here for understanding the problem and implementing a solution plan. And when you think about it, whenever you do your own problem solving, it doesn't have to be just math, but just solving a problem, whether it's fixing an appliance or you're solving a solution at home when you have to balance things or finding a way home because of a detour or some type of construction that's blocking your usual path home. You have to understand the problem. You have to implement a solution plan, and then you implement it, and then you reflect on whether it was good or not. And that's what we do in everyday life. Let's do it as well for mathematics. So this one here will have lots of information. It looks a little bit clearer to me. There's different types of things about the SQR, which is survey, question, and read, which you may be interested in looking at. So I would encourage you to take a look at these documents. This one's not that long. It has a lot of examples, but in terms of the length of it, it isn't really that long. I'll add one more thing here, cooperative learning groups. And it's, again, there's nothing wrong with working together on solving, but you do have to have them prepare, and you sort of have to train them to how to learn to work in groups rather than just one person doing the problem and the others are just waiting to write down the answers. So there's a lot of information here in this document, which will be online. It's actually, this is the link up here. and it's Florida. You'll see the link in the Blackboard documents. So this link here, and also this why is teaching problem solving important, is also going to be on there. So try to implement that in your unit and in your lesson plans, and that will make me very happy. And hopefully you can teach at least maybe a piece of that in the upcoming weeks. Take care. We'll see ya.